if you have any questions, let's go what we have.
The future research that you're doing, is that eventually potentially a way to create kind of a almost an equation to help people plan and understand, or will it always have to go back to really studying every site locally and understanding the very specific sites?
So kind of another goal of our research is, since we were doing, we were using those aquatic habitat zones to kind of say this general area is kind of one condition, or these are the situations or the conditions that's in that area. We might try and use some mathematical modeling to figure out what's going on, and you could kind of say that, if a certain amount of sulfate's added or whatever, this might be what is going to happen without going out and spending a lot of money doing all the analysis and research. So that's kind of a possible, future thing that we might do. So,
are there ways to absorb that methylmercury other than biologically? So you're thinking about the engineering side or the remediation of these areas. Is there a way to do that?
There are ways that people try to control the production of methylmercury and keep it out of fish from an engineering standpoint. And I guess in the big picture, I don't know how aware of this you guys are, but this whole estuary is, especially the lower part, is pretty contaminated. I mean, sort of from historic shipping and manufacturing and mining and everything. There's all kinds of nasty stuff in there. And there's two basic types of contaminants. One is organic contaminants, which are just made up of carbon, hydrogen, and oxygen. And then there's metal contaminants, which are, you guys know what metals are. And for organic contaminants, and I should say, so there's these two kinds of contaminants, and then there's kind of two approaches to remediation or engineered management. One is to leave the stuff in there and try to encourage it to degrade into a non-hazardous byproduct. That's called in situ remediation. You just leave it there and try to accelerate it degrading. Another way is ex situ treatment, meaning you dig it out and go put it in a landfill. And that's clearly more expensive, but in some ways it gets the mass out and might more completely take care of the problem more quickly. The issue is, for organic contaminants, it's possible for them to degrade to non-hazardous byproducts. Carbon, hydrogen, oxygen, if you let bacteria chew on them for long enough, eventually it'll just be carbon dioxide and water. For metal contaminants, a metal's a metal is a metal. It's not going to go anywhere. You might be able to change the form of it. And so in some sense, in situ treatment options for metals are a lot more difficult than in situ treatment options for organics. The ways people have tried to reduce mercury methylation, a couple ways. One is by sort of placing a layer of clean material on top of it, so that if you place clean material on top of it, then the biological communities will move up and populate that clean material, sort of being the formerly superficial sediment will be buried in the new superficial sediment. That's where the sulfate-reducing bacteria will be, but there's no mercury there because it's clean now. So in that sense, you can sort of try to control mercury flux out of the sediment by putting clean material on top. Another way that people have tried to do it is by mixing in non-natural organic carbon, so like activated carbon that people use in water filters and drinking water treatment plants. If you put this carbon in, it might soak up all of the inorganic mercury that the bacteria use to produce the methyl mercury. So if you could put in some organic carbon, then now the bacteria has no mercury to start with, because it's all stuck very strongly to this specialized organic carbon. Those are a couple of in situ ways. The alternative to in situ is just to dig it all out. But the trouble with that too is that it only takes a little bit of mercury to cause methyl mercury, and so you have to get it all out, and that's really hard to do from an engineering standpoint. You dig it all up, but as you're putting it on the boat, a little bit of it dribbles back down and settles back down the sediment. And if you don't get it all out, there still might be enough there to cause this